Welcome to our very last video for 7th grade. This is the last one for probability. And this one is called independent versus dependent events. Just going to kind of tie a little bit of everything we've done this unit all together. So first is some vocabulary. What is an independent event? Basically think of this is what we've been doing so far. One event does not affect the outcome of the other. So maybe you flip a coin. Sorry, that's the worst writing for a coin ever. And then you roll a die. Whether you get heads or tails on the coin makes no difference in what you're going to roll on the next one. They're really separate from each other. So to find the probability, you simply find the probability of each event and multiply them together. And that's what we've already done some of in an earlier unit. To find the probability of getting heads and rolling a 5, you find the probability of heads and the probability of rolling a 5. So here you're not trying to figure out how many combinations, you're trying to figure out what's the likelihood, the probability of a particular event. So this is where you're going to use the fractions. So this one says the spinner and number cube shown are used in a game. So we're using this stuff over here. What's the probability of spinning green? Well, there's one way to get green out of 5 possibilities. So 1 out of 5. What's the probability of rolling a 5? Well, there's only 1 5 out of 6 possibilities. We multiply together and we get 1/30. So we have a 1 out of 30 chance of spinning green and rolling a 5. So what's the probability of not spinning blue? Well, there are 4 things you can get that aren't blue out of 5 possibilities. And then what's the probability of rolling a 3 or a 4? Well, that gives me 2 possibilities out of 6. Multiply those together, and I get 8/30. And of course, we always look to simplify. In this case, we can divide by 2, and we get a probability of 4 out of 15. So you're simply finding the probability of each event separately and multiplying them together, something we did with one of our earlier lessons. But now is where we get to something new, a dependent event. And here's the big part. One event does affect the outcome of another event. So basically whatever happens first affects what happens next. Okay? So to find the probability of a dependent event, find the probability of the first one, and then find the probability of the second one given that this happened. So we write that as probability of B following A. So it might not be the normal probability for something happening. We have to think specifically about, okay, what's the likelihood after something else has already occurred? And it'll make a little more sense as we see it in action here. So this one says there are 4 oranges, 7 bananas, and 5 apples in a basket. So that gives me 16 total pieces of fruit. I want to know the probability of picking an orange and then an apple. Well, start with the orange. There's 4 oranges out of 16 pieces. So that part's easy. Same thing we've done before. But now I want to pick an apple. Well, there's 5 apples, but there's not 16 pieces in there anymore. Now there's only 15 because I took one of them. So because there's fewer pieces in there now, there's fewer things for me to choose from. And that's where this dependent event comes in. I took one of the pieces, so there's no longer 16, so now I'm picking out of 15. So now I go ahead and multiply. 4 times 5 is easy, that's 20. 16 times 15 is 240. And then I can divide each of those by 20. So I get 1 and I get 12. So I get an answer of 1/12. But it's that second probability that's going to be the careful one. Focus on what happened after that first one. So what's the probability of picking 2 bananas? Well, for the first one, I got a 7 out of 16 chance of drawing a banana. But assume that I picked a banana on the first one. Well, now there's only 6 bananas left because I took one of them, and there's only 15 pieces of fruit total. So the probability of choosing that second banana changes the 6 out of 15 instead of 7 out of 16 because one of the bananas is now gone. So I go ahead and multiply, and I got 42/240. Let's do a little simplifying. I think they can at least be divided by 2. So I get 21/120ths. And those should each be divided by 3. So I get 7 over 40. Let me double check here. 42, 2/40ths. Simplified does indeed give me 7 out of 40. But it's that second fraction that you have to be careful of. So let's see just a couple more. So you have a coin and a bag with 5 red, 4 blue, and 3 green marbles. So that gives us 12 total marbles. So these problems are going to be a combination of both independent and dependent. Because the first thing I'm going to do is flip a coin. So the probability of getting heads is 1 out of 2. Flipping a coin has nothing to do with what I'm going to draw out of the bag. So it's not going to affect drawing a blue. There's 4 blue out of 12. So 4 out of 12. But now I want to draw a red. Well, there's 5 red in there, but I've taken one of the marbles. So now there's only 11 marbles left over. So that first marble affected the probability of the next one. So now I go ahead and I multiply. 1 times 4 times 5 is 20. 2 times 12 times 11 gives me 264. They can each be divided by 4, and I get 5 out of 66. So it was that second piece that came after the first marble that was affected for it. So you got to really think through each of the possibilities. Which one, when is something going to affect the next one, and when will it be separate? So let's see another one here. We want to flip tails. Well, there's a 1 out of 2 chance of flipping tails on a coin. And now I want to draw 2 yellow marbles. Well, oh, make that green. My bad. Forgot I changed the color in the problem and forgot to change it in my work here. And then I want to draw 2 green marbles. I'll start with drawing 1 green marble. There are 3 green marbles out of 12 total. So that's my first green marble. But now I want to draw another one. I've already taken 1 green marble, so there's only 2 left. And I've taken 1 of the marbles out of the bag, so there's only 11 marbles left. Go ahead and multiply. 1 times 3 times 2 is 6. 2 times 12 times 11 is 264, just like it was in the previous problem. Go to simplify. And all I can do is, in this case, divide by 6. And I get an answer of 1 over 44. So think through each piece one at a time, but now you have to think about, did whatever happened first affect what was going to happen next?